It's the coffee. Oh. Also being protected as really hours.
Well, it's almost time to begin. I'll just say a couple of things before really getting started. First of all, as probably will become obvious, I'm not the originator of the material on the slides. And so there's 3 presentations, and I just sent them to Karen, and she'll post them on the IETF website, presumably any minute now. And but these presentations, the 2 large presentations, are actually taken from stuff that's already publicly available from my IEEE website. So that's one thing. Let's see. Oh, I guess it's time to get started. Well, before I forget, if I say something that doesn't make sense, or if you want more information about anything in particular, we only have an hour. But I'll do my best to make a short answer now. And you see my email address up there, and on average I'll respond. So please don't hesitate to send email. And if I don't know the answer, I will find it for you. So welcome to the wireless tutorial, 802 wireless. This is an update from a February presentation, and I have been assured that it would be a good idea for me to read this to you. I didn't write this. At lectures, symposia, seminars, or educational courses, an individual, for instance me, presenting information on IEEE standards shall make it clear that his or her views should be considered the personal views of that individual rather than the formal position, explanation, or interpretation of the IEEE. And so that's way more formal than I usually am. So I want to... Well, there's a lot of rigmarole about that. Typically, if IEEE wants to make a formal position, they will, to another body, for instance, IETF, they'll establish a liaison, and then the liaison statements will be vetted by various standing committees. I know of a couple in IEEE 802 wireless, and then people make an honest effort to make the statement say what IEEE says it thinks it should say, and then it's sent, but only after review by the wide community.
Like white papers?
No, this 802 wireless, well, I'll take that back. There is a study group, technical advisory group that makes white papers, but they're just to be construed as informational in the effort of people that are involved, not a statement of IEEE Standards Association. But on the other hand, they're usually pretty good anyway, so okay. I just don't, but if they're wrong, you can't sue IEEE. Okay. So I'm here to present the material. I understand most of it. I've been involved with a lot of stuff with IEEE 802 wireless, but unfortunately within the next 40 or 58 minutes or so, I can't really give you technical descriptions. And there's a couple of places where I can show some particulars, but overall, I'll try to explain to you why stuff is interesting and where it fits in IEEE. And then again, if I don't know an answer to your question, I can find out. I started going to 802 about 6 years ago. Was involved with 802.21, which is a more or less an interface group between IETF and 802. Lately, I've been involved with Internet of Things, technical materials, and that's largely in 802.15. Also, I've been involved with OmniRAN and the Standing Committee for IETF. OmniRAN is, I believe, going to have a presentation here in Int area sometime this week. I think, I don't remember, maybe JC Zuniga is going to do that. Anyway, all these documents, and it's all freely available. You can see the URL there on Mentor. Whenever I type ME on my computer, I go to mentor.org. And it's all there. It's usually pretty interesting stuff. The 802.11 material is here from, Dorothy Stanley created this. She unfortunately couldn't be here today because getting from San Antonio on Friday to Seoul, South Korea on Sunday is beyond the airline's capability, it seems. So I cut out all the sessions on Friday and flew over here to be here today, and she'll be here tomorrow in some frame of mind, and she's also going to be available to answer questions. Bob Hiley, I believe, will also be here in Seoul. He's the chair of 802.15, so practically all of this material is going to be updates just from 802.11 and 802.15. There's other interesting groups in 802. So here's an overall diagram. 802.1 is a very interesting area. It's, well, it's sort of switch protocols and so on. And wireless LAN is 802.11. 802.15 over here is, they call it wireless specialty networks now. It used to be personal area networks. And then you can see there's several others. .16 used to be all WiMAX. Lately, they've been doing some other interesting things. Coexistence has to do with things like how does .15 interact with .11, how do we interact with 3GPP, and so on. And then there's this .24 is a good place to get white papers, for instance. They have some IoT stuff, and actually I can't remember lately what they've been doing. And how did that happen? Come back. Okay. Okay. Well, you know, those wired connections are so finicky. So 802.11 has 359 voting members plus 12 ex officio and plus 115 that are going to be probably voting soon. And first part of my presentation is going to be all about the .11 stuff. And before I get there, I just wanted to mention that there's organizationally, .11 and .15 have various kinds of subgroups. The working group, for instance, is .11, which corresponds to an area in the IETF. Standing committees and task groups. Standing committee is doesn't have the same kind of delivery schedule as a task group. They can be monitoring or produce new work items as needed. But the task group is really working towards according to a schedule with a well-defined deliverable. And then there's study groups, which can be considered a precursor to a task group. And the task groups I've been involved with, they were preceded by study groups. And before you have a study group, you can have either topic interest group in .11, or in .15, it's just called an interest group in IG. So I'm going to try, I have a little cheat sheet here. So what's happening is that Dorothy gave me a lot of slides, and there's no way I could cover them all. So I'm going to not cover them all, and I just put these in the presentation so you'd know which ones I was going to cover. If you download it from the IETF website. Okay, so this is, by the way, up here you can see the sort of canonical form. This is a 802.11 document, and this shows it is 2016, and this is document number 500, release 1. So, in fact, just a second here. That's pretty much what I showed right here. 82.11, 16, document 500, release 1. So if you want, I can show you on Mentor how to get that stuff. Let me just take a few seconds to do that. Mentor. So here, if you go to mentor.ieee.org, you can go to .11 or .15. And if you go to 15, let's just say, for example, at some point, you will see here, voila, that Bob Hiley finished the document number 843, revision 1, and you're going to see this a little bit later today. So, so that's enough of Mentor for now. And let's go back to Dorothy's presentation. So this is just a description of what I'm going to be telling you about. And so this is actually an update from a presentation that was made earlier in February, and that was a very big update from a previous presentation made by Donald Eastlake. And so all of those slides are sort of batched together in Dorothy's presentation. Oh, you want the full screen? Thank you. Please don't hesitate to tell me that stuff, because I'm trying to figure it all out here. Okay, so so these things are still all up there, and you can download this presentation in its entirety, but I'm only going to go through part of it. So the update part of this has to do with what's happening since February, and we have this sub-gigahertz slide is basically done. I can't give you very much material about that. The fast initial authentication is, I think, of some interest. I'll say a few more things about that. And the revision project, I'm not going to say anything really about, but I just want to explain to you how important it is, because what happens is, yeah, let me go to this slide just for a minute. So what happens in .11 is that you start with this wireless, I guess, next generation. But anyway, this is where people come in with proposals on technical work that has to be done. And so then some of it is actually constituted into study groups and interest groups. And then some of that progresses into actual task groups with deliverables. And then the task groups work away for a while until they can come up with a specification. And then the working group votes on it, or comes up with comments. And when I say come up with comments, I'm not kidding. Some of them have like 1,500 comments, and every last one of those comments has to be resolved, and they're usually perceptive in some way. So and then once you get through with the working group, which remember is like IEEE area director, then it actually goes into the Standards Association, which is our sponsor, and that makes it much broader community for input, not just 802 wireless, but the entire standards organization. And then they finally get published. Well, what I was going to say about the revision project is these amendments, what it boils down to is you have 82.11, which happened a long time ago, and even before then. It's been around for almost 20 years. And then amendments get made that make serious changes to the evolution of the standard, and people can't find all that stuff very easily. So the roll-up or the revision actually puts all the amendments into a single document, and this one for .11 just is published. So it includes these ones here, for instance, TV white space and so on. AC gives you, I think that they provide data rates up to 7 gigahertz actually, or gigabits per second. And so it's interesting stuff. Well, anyway, back to where I was. In addition, okay, so I talked about these. And then new activities is this Wake Up Radio task group, which I think is super important. And it grew out of this long range low power. Remember, I mentioned that there was interest groups in .11. So that was a successful effort, and they have now a project to make an amendment for that. There's also a topic interest group on light communications. So something about Li-Fi here, which I personally think is a terrific new area. Just well, that's gonna make a huge impact. And then there's a lot of interest and discussions about interaction between .11 and 3GPP, and I'll have more to say about that later. All right, so, oh, wait a minute, let me make sure, yeah. So this wake up radio, again, I've only got another, maybe at the most, 20 minutes to talk about .11. So I can't go into very much detail at all, but one way you can really save a lot of battery consumption is just by turning the device off. And then naturally, if you do that, you have to have a way to wake it up. So you can see how Dorothy has organized this information to show the use cases and the parameters for the technology. And here, since you have now, if you go in and get this document, which will be on the IETF webpage or from Mentor, you will be able to follow these links to get all the interesting technical stuff. By the way, I should say one little thing about standards organization and IEEE. They require two documents. One is project authorization, and that's called a PAR. And so you have to basically, they're not going to approve your project unless you can tell them what you're going to do. So this is the recipe for the deliverables for this wake up radio. And then not only are you going to have to tell them what you're doing and what you're going to deliver, you have to tell them why in the heck you're doing it. And so basically this boils down to what is the commercial advantage of this technology, how will it affect the evolution of .11 and you know, the market and so on. So that's all important stuff for completing and getting a project approved. Here is a list of the currently interesting stuff in .11, in other words, projects that really haven't been completed. Some of these are actually completed, like for instance, the fast initial link setup at .ai is completed and the revision is completed. So this list could be considered to be shorter, but I don't want to go through each one of these in specifics. I already showed you this picture, but I want to now at least emphasize that some of these are, I think, more important or more interesting to IETF folks than others. So for instance, this high efficiency wireless 802.11ax, this is, you might say, will become essentially next generation from AC. And AC is the one that has high multi-gigabit data rates. And so 11AX is just a huge, huge effort. There's hundreds of people in every single meeting, and that translates into dozens and dozens of technical proposals and arguments. And I don't go because I'm in .15, but I stop by every once in a while. And this one over here, this fast initial link setup, you can see 11AI is already in sponsor ballot, which means that the working group has done what it's basically wanting to do, and now it's just responding to comments. Okay, other than those things, there's we have some known areas of mutual interest between IEEE and IETF. One is that this internet draft trying to describe use cases for and problems with multicast. So multicast is crucial for deployment of IPv6, and yet multicast has numerous issues with 802.11 specifically, and even worse issues with 802.15 in a way. So on the one hand, you have a fabulous technology, IPv6. On the other hand, everybody wants to run it over wireless, and the multicast stuff has essentially got bugs. So that's what the point of this document is. And this has been sort of on hold for the last 4 or 5 months because, well, we ran out of time to do anything on it. But it's going to be picked up again as soon as we can get to it. There's a couple of things I don't know much about. Dan Harkins has some privacy tools, opportunistic wireless encryption, and this salted password thing. So I think those are probably pretty straightforward things to read about. And then there's also some ongoing work with CapWeb. Is CapWeb still active? I don't think CapWeb is meeting, but anyway, people use it for .11 stuff. So that's the end of what Dorothy said was updated since February. But I had a couple of other things I wanted to emphasize from the other slides, and I'm just going to go directly to them. Again, this will be on the IETF website, and it's already on Mentor. You can go get it. I'll just show this picture anyway. So we have this body area network. And then around that is PAN. This is 802.15 stuff. And by the way, in case I don't mention it, but later, .15 is shipping 1 million devices a day. So it's a pretty good choice for IoT stuff. And then we have 802.11. .16, which used to have WiMAX in it, was considered a metropolitan area network. And then we have TV white space stuff out in regional area networks, as so-called. And I wish I had a glass of water, but I'll get one shortly. So here's a picture of how dominant the Wi-Fi stuff is over cellular radio. Thank you, Tim. I thought if I dropped a hint, somebody would help me. That's appreciated. Okay. Well, if I drink all this, it'll be a miracle. Okay. So anyway, you can see from these pictures that Wi-Fi is really carrying most of the world's wireless data. And unfortunately, I think maybe one of these is 2014 and another one's, before that. And it's also from the UK. So you can't absolutely guarantee that the same happens here. But I'd be willing to bet that in the US, it's even more pronounced. So what that means that Wi-Fi is really, really, really important. There's a Wi-Fi Alliance, which I can't tell you very much about, but there's a pretty, I think, a great amount of cooperation between 802 Wireless and the Wi-Fi Alliance. And IEEE doesn't do any certification or anything like that. And in fact, I think Wi-Fi Alliance you might consider to do more of the systems level stuff instead of IEEE. Okay, so I want to go to slide number 29. By the way, I'm racing ahead here, but does anybody have questions so far? Any specifics? Don't hesitate to interrupt me, especially to tell me when the screen's not working.
So Charlie, I had a sort of operational question. I was looking to find these slides, and I'm having trouble finding them.
Okay.
Am I the only one, or because they don't appear to be on the IETF website?
So that just means I didn't finish them until about an hour ago.
Okay.
And so, but I sent them to Karen, and so she'll get them up on the website as soon as possible. Okay. But these ones are already available on Mentor if you want to go over there.
I'm looking now. I'm just not sure where to look.
Okay. Well, I'll tell you what. Let me take another few seconds break here, and I will do that. So if you go to mentor.ieee.org, you'll see this. And then you go down here to 802. And then you can go to either .11 or .15. And so, for instance, here, if I go to .11, and I think Dorothy's presentation is 500, so let's just go Control F500. By golly, there it is. Okay? Yep. All right, so this is just, this is more technical than I probably will get anywhere else in this presentation. But the idea was that whenever you get into it, oh, man, there's just so many moving parts here from current slide. Okay, so 11AI, this is the fast initial link setup thing. They were faced with this problem. You go over here, and if you're using the authentication from what then existing 802.11, you had all these protocol steps. Well, you know how long that takes. I mean, it's aggravating, right? And so it's good enough, long enough time to drop lots of packets and so on. So they spent a while figuring out how to make it better. And now I don't know if this is, for instance, beacon probe response is probably 2 messages at least. And here we hopefully don't have too many more than 2 authentication messages. But anyway, diagrammatically, it looks a lot better. And they've also allowed for public key and shared key variations. Okay, now, so here's AX. This is sort of the, you might say, the next generation of 802.11ac although it's not exactly a linear thing. But the point is that everybody expects that AX will be the future specification that allows extremely high data rate applications. So focus on dense deployments. Now, this is actually a very important point, because for one thing, if you have a lot of people in an apartment complex, that's a dense deployment. For another thing, if you have a lot of enterprises on a crowded street, that's a lot of deployments. And so what it boils down to is that you have to do something to try to avoid interference between all these access networks that are separately managed. And for example, one thing that I believe we're going to do, and I don't know what the current status is, but they were going to deprecate 802.11b just for the simple reason that B takes up too much time on the air, and it crowds out new standards like 11ax. So anyway, as with all new technologies, it's got to be faster and low delay and more efficient and better power consumption and everything else you can think of. But I think they're making an honest effort. Now, I'm not a PHY person, a physical layer person, but when I see 1024 QAM, I think that's pretty hot. That means that they can get a lot of bits per hertz of bandwidth. And so I don't know how many bits you get out of, what is it, quadrature amplitude modulation. And besides that, they have multi-user MIMO and other things. So that means that you can have pretty high efficiency and accuracy in extracting your bits, and you can get a lot of bits per hertz. So this is really going to, well, it's just going to be fabulous. So this is, they talk about also, if you are able to do some sort of management between your base stations, then you can have spatial reuse. So you can see here, if you have, let's say, 7 different frequency bands in your that you're allowed to allocate, then you can have a pretty high spatial reuse in this way. And I wanted to emphasize this slide just for a moment. So the way that, and actually I'm going to be honest, this is slightly beyond my understanding. I couldn't tell you exactly how these things, where the frequency bands were, but I know what this means, this orthogonal frequency division multiplexing. And what it boils down to is that you have, I think these are, time slots, and you can get these frequencies and so on, but you have, but per slot, it all belongs to one user. But now you can actually slice it up and have, and then in this way they're able to do 2 more users into the same amount of a spectrum and time slot. Okay, so that's an example of AX. And how am I doing here? 37. Yeah, I wanted to at least mention 802.11ay because here they're talking about 20 gigabits per second at the access point. It is high spectral bands, but well, I think 20 gigabits per second is pretty cool. And so I think we have a lot to look forward to. They're showing pictures here, buses and so on, and well, okay. So there's that. Now 41. This is an interesting picture. It shows that the same MAC layer in 802.11 is able to serve .11a and B and G and N. And, we've been using these ones here for a long time. AC is coming in, and AX is in process. So all these things effectively can be used without too much problem from the IP, because it uses the same device driver in many respects. So this is a good situation. You can pick out which physical layer option you want and not have to change your network layer software. And I want to come back to this idea a little bit later. Should I? Yeah, okay. So now for something completely different, I just wanted to mention something about .19, because when you have the situation where unlicensed band is carrying the heavy majority of the world's data, and 3GPP is collecting the majority of the world's wireless revenue, then something is eventually going to happen there. And what's happening is there's something called LAA, which I forgot exactly what it stands for, but what it means is that LTE and 802.11 are both planning to use unlicensed band or license exempt spectrum, and they could crowd each other out. So there needs to be a way for LTE folks and IEEE folks to coexist and let the user use whichever one is best for their needs.
License-assisted access.
License-assisted access. I see. Well, that just makes my imagination go wild. So I'm going to leave it at that. But I strongly encourage you, if you're interested in coexistence of LTE or 3GPP stuff with IEEE, to take a look at this. And this is a topic of intense discussion at every meeting lately. Yes.
You know, I know the Wi-Fi Alliance is working on that as well. Were they doing the interoperability testing and then feeding it back to them?
I don't know the answer to that, but let me copy it down.
What I heard about that was the Wi-Fi Alliance was concerned that LTE was going to start trashing the Wi-Fi spectrum. So they were pushing for some interoperability mechanisms to reduce the damage.
I'll just say that the discussions on the IEEE side have been intense. And it's like everybody sees this train coming and nobody wants there to be a wreck. So it's going to require some actual honest effort on both sides. Okay, so I mentioned briefly before about the topic of multicast, and we have some performance optimization things, and we have this draft also with, well, there's a draft with Mike McBride from PIM, and there's a draft that I've been involved with Dorothy and JC and Dan Harkins. So, but this is important because, and there have been in IETF side a lot of improvements for avoiding multicast problems with IPv6. So I think this is an evolving area and it needs more attention, and hopefully we'll be able to make a document that captures the important points. And that actually, what I just was talking about. Okay, so additional topics of mutual interest, just briefly. There's white space. There's RFC providing access to the white space databases, and IEEE had 802.22, had a lot to do with the white space stuff. I mentioned before there's ongoing work with CapWeb, and then 802.11 uses IANA registries to define parameters for, I think that's a DH. Now, this is recent actually, but I think the DH stands for dispatch header for 6LoW. At least I'm aware that that's happening with the 6LoW guys. They have a internet draft. It's I think it's past last call, and ISG is looking at it. Oh, so just overall, I want to mention that in my opinion, IETF and IEEE work very well together. There is an IETF IEEE coordination committee, and they welcome inputs. And as far as I can tell, they've really worked hard to have constructive resolutions. Okay, well, that's all I'm going to talk about from the .11 side. Any questions before I move to .15? Well, you don't have to ask now. You can send me email later if anything comes up. And let's see here. Okay. Now. All right. So this is a slide set from Bob Hiley. He's the chair of 802.15 and has some other affiliations as well. And I have his email address up later, but you can send any questions to either Bob or me about this. And I've already made this disclaimer, so I will just remake the disclaimer. Okay, so here's the same picture. It just shows 802.15 in its home position with 802 wireless organization. And it has, before, remember, 802.11 had about 300 and let's say 70 voting members. Well, .15 only has about 100 and something, maybe around 100. But in many ways, the groups are run as similar, but they're not absolutely the same, but there's a lot of similarities. Okay. Oh, one thing I should have mentioned before. Remember, I mentioned a little bit about, well, for instance, in this, if you have a document or specification, then the task group will first of all get a document that's ready for presentation to the working group. And the working group in our case is 802.15. For instance, one task group recently finished was layer 2 routing. And so then the .15 makes comments on it. And then after that's done, it's sent up to our sponsor. And our sponsor is at the next higher level of this organizational chart, which is 802 Local and Metropolitan Area Networks, LMSC, which, if you remember that thing on Mentor, is one of the document subdivisions on Mentor, which leads you to 802.11 or .15. So sponsor is, in a way, providing the legitimacy for the standardization effort, if I can say it that way. And by the way, if you want to be a member of the IEEE Standards Association, you just have to pay $50 a year, and they will let you make comments on all those documents. It's open for all participation. Okay, so here's the scope and purpose of 802.15. Activities focused on wearable devices to start off, which were personal area networks or PANs. But that's been, it's really outgrown that a lot, and it's really tending much more towards, I guess, process control and IoT sort of things. So the data rates are a wide range of data rates and long range communications, and 100 megahertz to 800 terahertz. Okay, well, I'm not aware of anything at 800 terahertz. I wanted to ask Bob about that, but it's anyway a wide range. Yeah, I guess so. There is an optical OWC, optical wireless communication effort there. Good point. Thank you. Okay, so they stopped focusing directly on personal area networks, but specialty networks, and I'm not sure exactly what that word is supposed to mean, but it probably means whatever, not wireless LAN. So typically short-range communications, and Bob says if it's not LAN, MAN, RAN, or WAN, then it's probably 802.15. And there's one distinguishing characteristics, what I'll show a little bit more about this later, is that it's the only working group with multiple MAC layers. But just as a show, can I question, how many people here know what MAC layer is? Okay, well, you see, now you're supposed to stop me and ask questions. MAC layer is media access control. And what it means is that when you send a packet down from IP, it's got a bunch of bits in it, but you can't send it unless you can actually obtain a medium on which to send those bits. And that means that you got to fit into the scheduling, this resource, and the wireless or wired media. It has to be actually having a time at which it can be sent out on the medium and a frequency upon which it can be carried, and all that stuff has to be. It's a matter of protocol, just like IETF works on protocol, but it's protocol. You might say restricted usually to one link, or in other words, the medium between two neighbors. So this is a crucial thing to understand about IEEE, is that they spend a lot of time with optimal scheduling of the medium, and also fairness. You want to have the medium to be scheduled fairly so that all contenders are allowed to get on to that medium and make use of it. So I guess that's as much as I need to say about that right now, but I urge you, please, if I make a technology or a statement like MAC layer and you don't understand it, you have to stop me, because otherwise I can't get the message across. Okay, So 802.15 completed projects. Well, they originally did something for Bluetooth, and then people were using that for a while, .1, and Ericsson was using it too. But for some reason, there was divergence between 802.15 and Ericsson, and then Zigbee came along and did something else again. So, and again, there's a strong requirement for .15 and .11 to interact beneficially and share the medium. So that's a coexistence document. .3 is a high rate version of 802.15. It's still in quite active use. And then they actually decided to use MAC addresses, 48-bit MAC addresses. I don't know. So one thing is not here, but about .15, the design philosophy for a long time was, we're not going to do anything for you. You're going to have to do all of that MAC layer stuff up in the a lot of things like interpreting multicast or you might say fragmentation and so on. All that stuff has to be done outside of our spec. Well, the natural result of that is that all these crucial things that have to happen, like for instance fragmentation, got done in more than one way. And so now they're trying to backtrack off of that and actually provide standardized mechanisms for a lot of common things that have to be done beneficially below the layer 3. Okay, so they also go in the other direction, low rate stuff for energy efficient PANs and so on. PAN is always personal area network. So here's a list of the .4 completed projects. .4, as you can see, has been the center of a huge amount of activity in IEEE 802. They had ultra wideband PHY. They have a special, PHY is physical layer, and that's where you get down to enabling the discrimination between noise and actual bits, and what is the modulation technique that's going on, and what is the frequency band, and what is the what are the regulatory requirements. For instance, the government gets in there and they can tell you, you can do carrier sensing for this amount of time, or you have to, well, anyway. So there's a lot of things like that. And I have to tell you, I'm not aware of most of what the technical content of these completed projects, because a lot of them were done before I started coming in 2010. So I will not go into very much detail on that. Well, just to mention one last thing down here, this .u. I think this was set the world's record for the fastest standardization. They started like a year and a half ago, and all they wanted to do was to put in this band in India so you could use it with 802.15. So there wasn't much question about how to do that. More completed projects. It's revision C. So for 802.15, it's the same importance. We want, in order to avoid having to go to so many different documents to get answers, they roll up all the amendments here. You can see these 7 different amendments into, and this was just finished about a year ago. .6 is body area networking. I have not been at all involved with that. .7 also has to do with visible light communications, but it's really, my understanding is it's a lot more like you come up, you put your device onto the move, and you download a movie across a very short link or something like that. 802.15.9. Bob Moskowitz is known for quite many people in IETF, and he was the chair for that group, and they made it says key management protocol, but what it really boils down to is a container protocol for key management. So it allows you to do key management in multiple various ways. 802.15.10 is layer 2 routing, basically mesh under. So, and that's done, but it's not completely done. It's just finished with sponsor ballot, and so it has to go off to one of the document producing agencies within 802. With an 802 wireless organization. .3 has a couple of active amendments. One is up at the terahertz band for point-to-point data center. Anything with data center is important, but I don't have any more information about this. I can find if you want. And then the high rate data communications also for here they show for specifically MPEG file transfer. So I think the idea is you show up at the airport, you're in a hurry, you want to download 10 movies, you do it. About 3 seconds later, you've got 10 movies, and then you go to sit in your seat. .4 has a number of active amendment projects. There's location-based service thing. That it seems to be on hold. I'm not exactly sure why. There's also a location or localization effort in .11. .S for improved spectrum utilization. Apparently, they're getting close to being done. High data rate, HRP. They're talking about higher. So 802.15.4 was set up to be low data rate and low power, and heavily guided towards that, which also carried along with it this design philosophy that they were not going to do very much for you at layer 2. Well, time has moved on in the last 10 years, and now we have a lot more capable and low power processors, and so correspondingly, Karen's here, and she's smiling. Okay, thank you, Karen. Oops. I'll do this in a few minutes. Okay, thank you. Okay, so anyway, with faster and low rate actual CPUs and processors, you can get a lot more mileage, and so we have now had this other PHY layer called higher data rate PHY, and it's also done. It didn't take long to do that one. Regional subband. I think this is. Remember, I mentioned about .V or .U, which is only for India. Well, when they were doing the process for India, they discovered, hey, there's a lot of other countries that have had regulatory changes too. So let's go make these things available for Mexico and Brazil and New Zealand and all that. So this is also basically done. It's going in for sponsor ballot and should be done the next few months. Now, I want to also point out that I'm aware that probably you don't care about a lot of this stuff, but you have to know that IEEE is there to make these sort of frequency bands and PHY layers available for use, and hopefully it will never boil up to something that really matters at the network layer and above. Okay. Question? Yes. No, I have to be honest and tell you I only heard about half of your words. So if you could say it louder or come to the mic.
So we have different frequency bands that are specific to geographic regions. So
Yeah.
if you have devices, say in Brazil, they won't work in China.
Okay. Well, so you asked if there's devices that use all these frequency bands.
Yeah.
Well, there's not, because they haven't been standardized. And so every one of them has to have some sort of rule about what is the center frequency and what are the power allowances and what are the guard bands. And well, maybe Stuart has some more to add about that.
Well, if I understood your question correctly, I think I can add something about that. There are already radio devices that are legal in one country that are not legal in other countries. And even 802.11 Wi-Fi has this property that in Japan, I think channel 14 is allowed, but in the United States it's not. And most Wi-Fi devices, because they're on mobile devices, in the old days, you could sell a product in one country and assume it would never leave that country. Things are more mobile now. So now there's actually communication with the access point. So the access point will tell your phone which channels it's allowed to use based on the geography. And then you could buy an access point in Japan and take it to the US, and you would then be breaking the law in the US by using that access point. So this is an issue that people have to be careful of.
Okay, thank you. Okay, so .7 is it's not .11, it's not .15. Oh, wait a minute, I'm sorry, but it is .15, and there's a similar group in .11 for this, but it's not 802.15.4, so it's not related to the low power .4 work. Anyway, so they have also some optical wireless communications with visible light, and this is they also have some discussion in that group. I haven't been in this group very much, but apparently you can just take two cameras and cause them to be also communicating packets over their optical links. So, and then there's this peer-aware communication, which I really don't have very much to say about. I think it's not only infrastructureless, but also I don't think that they have any sort of forwarding or multi-hop operation. So I have a lot more to say about .12. This is a relatively new thing. We just started first meeting a few months ago. I mean, our first meeting is a task group. Before that, there was an interest group and a study group. So this is the effort here is to repair some of the lack from 802.15 from a long time ago to try to actually provide standardized way to use the various PHY and MAC layers of 802.15. So the vision was to simplify the use of .4. Now, right now, this is only for .4. It could go to .3 as well, and we don't know about .7 yet. But anyway, the point is that we want to allow a simple reconfiguration and using essentially, for instance, you want to be able to use the same device driver no matter which country you're in, as one example. So so that's the idea, and we want to be able to use the various protocol stacks in the same way that .11 and .3 use them without changing, depending upon, you might say, low-level details. Okay, and we also want to maintain backward compatibility with existing 802.15.4 devices and applications. Plus, we're going to take layer 2 routing and the KMP. This is .10 and .9. And from IETF, we're going to be enabling 6 low pan and 6-tish, all in with the same upper layer interface work. So I think this is really interesting work for IETF, and when we have a lot of the, you might say, interest group and study group effort for ULI was done. We were talking with folks from 6-tish and 6-low all along the way. So what it does is to give the 15.4 devices, well, I think I already said this, standard interfaces and primitives in a modular way. Modular meaning that you can add new features inside 15.12 as people decide to do the work. That's just as an example. You might want it to be that .12 does ranging no matter what the specific frequency range is and so on. And one thing that is going to be part of this is to use ether type and the dispatch IDs so that we can packets that come in will be able to specify in the same way that ether type does. Ether type will tell you what the where to send the packet in the protocol stack, and we want to have the same feature for .4, 802.15.4. Okay, so fragmentation is well. I mean, we don't actually have to specify fragmentation because 6LoWPAN already has a fragmentation capability, and 802.15.9 already has a fragmentation capability, but we have to allow it to all coexist so that the higher layers don't care that much. And as mentioned, we're going to include layer 2 routing and KMP as part of that. So I've got 7 minutes left. How much more material do I have? I knew this was going to happen. And please, if you have questions, even if I'm not going to finish all the slides, please don't hesitate to stop and ask. So I have a picture which I'll show shortly, but what we're going to do, what we have is essentially an architecture to allow modular extension and the dispatch capability plus the interface to the MAC and the PHY layers that can be done in a way that we can actually make forward progress. And I mentioned about the regulatory. Okay, so ether type is to help with using multiple protocol stacks on top of 15.4. And I should also emphasize that we want to avoid problems with having to have high layer knowledge of low layer regulatory requirements. So here's a picture that's got way too much information, but Pat Kinney insisted that I show it. So I'll try to parse it out a little bit. So here we're going to have V6 stuff coming down into, to keep in mind, this is all 802.15.4. And that means that down here, the MAC layer stuff is 15.4 and the PHY layer is 15.4. So for example, some of these new amendments are enlarging the ability for more PHY layer to be included in the .15.4. So this is a simple example. We have V6. My contention is that most V6, or maybe all of V6, is going to be going down through 6LoWPAN into .4. The only way that wouldn't happen is that if people, for instance, get a better compression technique and it's not standardized in 6LoWPAN or something like that. But anyway, we have modular blocks for 802.15.9, which is key management, and then .1x. 6-top is a 6-tish interface to allow the scheduled time-scheduled operation. L2R layer 2 routing is mesh under, and then this management protocol is showed as a regular square box, but it's actually large because there's a lot of 15.4 parameters that have to be set up, mostly with default values, but they have to be done. And so our task with .12 is to allow those things to be done regardless of the MAC layer and PHY layer. And then we also want to allow essentially a pass-through operation so that when .12 doesn't have anything to do, packets will just flow out to the proper MAC and PHY layer. And this diagram, by the way, is in flux. And this is where we've been focusing our effort for the last several months. Okay, well, that's enough for about .12. I have one more really important thing I want to mention. We have interest groups in 802.15. There's one about dependability. This is actually seemed to be picking up a little bit of steam. Recent presentation. By the way, you can get all of this on Mentor. If you go into 802.15 and look in there's a pull-down menu for the interest groups and the task groups, and one of them is IGDEP, and so you can go get all the stuff about this. So this could be an important effort, but reliability, well, if you're doing vehicular, for instance, you kind of want to make sure it actually works. High speed or high rate rail communications, I don't pay much attention to that. The terahertz interest group, I haven't followed that, but low power wide area I have been following. And here, this is actually just recently turned into study group. So I think this should be changed to say study group. So low power wide area networks are very interesting for many applications. And tomorrow will be LP-WAN meeting there's a new working group in IETF for LP-WAN. And the thing is that there's a lot of proprietary interest in this stuff too. And so we want to find out what our gaps are. So there's a lot of discussion in this LPWA, and I should say study group, about finding what work, if any, needs to be done at the IEEE 802 wireless area because of any gaps in their existing standards. And maybe there aren't any. We'll see. It's not an effort to create work. It's an effort to be responsible to our customers. So for instance, we have 802.15.4K and G, which has already been done as part of the 802.15.4 standard. We have Sigfox and LoRa, and ETSI has some efforts, and 3GPP has this narrowband IoT. And one of my things to do recently has been to learn about this, but I don't know anything about NB-IoT right now. And there's also a low power group in 802.11. So what LPWA will do is we already have got scenarios for the kind of work that should be done. Look at the channel and interference models, and you might consider this to be also an exercise in coexistence, and actually look at the performance of what we have now. So I'm now down to 0 minutes almost. I have to mention the IETF Standing Committee. This is the 802 correspondent, or you might say the other half of the, there's an IETF, IEEE group that's meeting here this week. I think if I remember right, it's on Wednesday. But anyway, you can take a look at that. And what else can I say? Yeah, I think I can't say anything more about that, but I do have to make a correction. And so let's go back to this one right here. So this was the message from Karen a few minutes ago. If you want to provide feedback, please go to SurveyMonkey and express your opinion. And I specifically want to ask anybody to tell what didn't work about the presentation. And if you tell me that it was too much material for an hour, I will absolutely believe you. And you can say which parts you didn't want to know about, you know, and maybe we can leave some of that out. Or maybe we can convince Karen to give us an hour and a half next time or something. We'll see. But whatever the purpose here is to make sure that we're all, you know, working together, and to make sure that you have awareness of how to get the materials that are of interest and provide. And again, Bob and me and Dorothy will be here this week to answer questions, and I do not at all mind if you stop me from getting a cookie to ask me a question. So I guess that's it. Thank you very much for coming. Or if you have any feedback right now, don't hesitate to ask questions.
Where do you see these materials, they feed on 5Gs?
5G, okay. I'm not talking about 5G.
I know, but some of the...
well, okay, I'll say a couple of things. The 802 Wireless is actually, there's an executive committee study group for 5G, and they've been spending a lot of time trying to figure out how best to tackle the problem. They want to know whether or not to closely align their efforts with 3GPP, or to simply try to avoid any major conflict, or how to beneficially engage. And I'll just mention that a lot of discussion has been around the following fact. 3GPP has a lot of people whose job it is to do 5G, and IEEE has a lot of people whose job it is to make sure that those MAC layers and those physical layers really produce the bits in the proper way. And exactly how those two areas of expertise meet has been the subject of discussion in this 5G interest group. And that doesn't exactly answer your question, but it's the best I can do. Okay, Well, thank you very much for coming, and look forward to any more discussion later in the week. Thank you. I bet you want this bag.
I do want that back. And I need to just send, I can
Oh. Well,
edit or.
you know, I can, why don't I just send you this properly edited presentation?